More back to basics 3D printing fun. Today we're going to go through step by step how to make a functional part. Hello everyone, Chris here. I'm getting ready to start a video series where I show you how to replace the main board with a Big Tree Tech main board on this King Rune KLP1. Now this KLP1 was the original one. It didn't turn out so well. King Rune did send me the latest version and it is much better, but I can't leave a good printer down. I have to fix this while showing you what the advantages are to upgrading a main board. That's kind of my thing. But for our Back to Basics series, this is a great opportunity to show you how to create a functional part by creating a new mainboard mount for this printer, because the mainboard I'm going to be using from Big Tree Tech is not the same footprint as the default mainboard. So that's what we're going to do today. So let's take a look at the printer, take a look at the different mainboards, then we'll jump into Fusion and create our adapter. Here's our KLP1. It really doesn't matter for this video, but I thought I'd give you a look at it. It's dusty. It's been sitting over there in the corner for a while. I had a lot of problems with the original mainboard for this machine, so it's a great candidate to swap it out. The mainboard lives under the machine in this area over here. There's just some metal standoffs that you bolt it down to. But I've already removed the original one. It looks like this. But we're going to be swapping it out with the Big Tree Tech mainboard. Big Tree Tech sent over this Manta 4 for replacement. And you can see the default one versus the Manta 4. This one's a lot different footprint than the default board. So what we can do is create a 3D printed adapter that will fit our new main board while also fitting our existing standoffs, so we can use the same area. We can put the board in the same space as the old board. We just have a mount or an adapter to make that happen. So that's what we're going to be creating. And remember, this is the Back to Basics series where I'm going to show you how to create a functional part to solve this problem. If you'd like to see more about the Big Tree Tech Manta M4P board or the project where we swap it out on this King Rune printer, please hit subscribe and hit that bell for notifications, because we do release a video every week. This series will be coming out soon. But now let's take a look at the boards we have, what we have to do to get it to the mounts on this printer, then we'll jump into Fusion and start creating a few things. So here's the existing board that came with the printer. Here's the Big Tree Tech board we are going to be swapping in. Now you notice that they're quite a bit different in size. Now there's a couple of ways you can do everything, right? But a lot of times you can find schematics telling you where the holes are located so that you can mount these up. Big Tree Tech always publishes that. I'm not so sure about this board, but nevertheless, you can just take your ruler and kind of plot these out. Now the old board did have some stuff coming out the back of the printer, or the side maybe, in some through holes. We'll talk about that. Notice we have that here, but we also have lugs here that have wires going out, so it's not going to be that easy to do the same thing. So we need to plan for this bolt pattern, these 4 screw holes, and these 4 screw holes. So here's my plan. We have these standoffs here that the old board sat on. Now there are holes down here to allow for these ports to come out the side. We're not going to be able to do that given the new Manta layout. I don't really utilize these, but I might actually utilize a USB inside this case. We'll see that more in a moment. But I want to make a plastic bracket that attaches to these standoffs, and then I'm going to mount the new board somewhere in this location between those standoffs. That should give me enough slack to use the existing wires. I don't have to change up a lot of the plugs. Plus, this does have a piece that goes over it to enclose it. I want to make sure that there's enough room because we have to put stepper drivers on here, so they're going to be just a little bit taller. So we're going to create an adapter that uses these standoffs to mount this board. As I said before, sometimes you can find diagrams that give you the sizes and the distance for all these mounting holes. Big Tree Tech has great information, so they're easy. You can just head to their GitHub page, go to repositories, and search for the board we're trying to use here. We'll just do Manta. Here's our M4P. And then in hardware, there should be a picture of this layout. The one labeled size. This doesn't give you everything, but it's going to give you a good idea where some of the holes are, how big the board is. So we can use that for our measurements. Now for the King Rune board, I did do some searching. They do still sell this board, and they have kind of a pinout here, but they don't have anything that has the sizes on it. So we're kind of on our own. Not a big deal. It's not a very complicated thing to mock up, and it'll be good to see it done anyway. So we're going to start with a blank sketch here in Fusion. Document settings, we want millimeters, and origin, we're going to turn that on. So let's grab some rough measurements from our board. So we'll start with the King Rune side. Again, I'm just going to create a bracket that goes over those standoffs, but let's go ahead and get the whole board. And these can be pretty rough measurements because we're just looking to mimic what's on the standoffs. So we're going to say it's 130 by 100. That's pretty easy to model up. So again, we're going to go top down. I'm going to grab sketch. We're going to start drawing from the top, and we're going to start in the center. 130, 100. So there's the base of the board. Now we need to know where all the holes are. Now I'm going to do something just a little bit different here. Because I need some clearance, I need as much clearance this way as I can get, I'm going to create a bracket that goes down over these standoffs. So it will slide over these, it will be the same height as these are, and then we can screw that on. Then we'll put holes in the center of it to mount the new board on. So I need to know how big these standoffs are and how deep they are. So we'll just go to the calipers. They're about 5.6 millimeters and about 4.5 deep. And to get the location for all those standoffs, it's actually going to be a little bit easier to measure the board, especially measure it and show you at the same time. But the holes look to be the same distance away from the outer edge of the board all the way around, so that's a good place to start. You can kind of measure from the center. That is roughly 4 millimeters. We'll just take a look at all these from the edge of the board. And remember, we're measuring to the center of the hole. 4 millimeters looks pretty good. We'll start there. We do have a wonky corner over there. It's been cut off. It's not lined up with the other holes. We'll deal with that here in a second. So here's where dimensions come in. Dimensions will lock whatever face or feature that you're putting in place so that you can change it as a whole. It's the way you keep track of where things are in Fusion. So we said those standoffs were 5.6. Let's create a couple of holes. And you can make the holes relatively easily equal away from one another, but you need to make them the same dimensions away from the edge of the board, this square we already drew. So 5.6, I want them to fit over the standoffs well. Let's do a 5.8. And we don't know how far that is from this edge. We're going to take care of that in a second. But we're creating circles here. I know that they're both lined up vertically with one another because of the same distance away from the edge of the board. So if you just start tracing down, you'll see that blue line. That will make it line up with that top hole. Again, 5.8. Then same with these holes over here. We'll just keep dragging over from this one, 5.8, and then same with this one. If you drag up from here and then over here, it's going to tell you when those two intersect, right there. So we know they're all square with one another, 5.8. Now we said that those holes were 4 millimeters away from the edge of the board. So here comes dimensions. So this is the one with the cutoff down here. So we know that we can do this edge. So let's just do that one first. So if you click on the sketch and you right click, you're going to say sketch dimensions or the D key. And then you can drag a line out to what you want to measure from. So we want to measure the outside of the board. You can see right now it's 7895. If you just click on that, it's going to let you edit it, and we're just going to put in 4. That's going to move that hole 4 millimeters from the center from the edge of our sketch here, our board. And we're going to do the same thing for these other sketch items. Click it. We're already in the dimension tool, so we'll click this line, 7895. Let's change it to 4. And then you can do the same thing for the other direction. We'll just click it, go to this top line here. It was also 4. Then move on to the rest of the sketches, and you'll just do this for all of these holes. Now all of our holes are 4 millimeter away from the edge of our sketch here. These two holes here are an equal distance from one another, So if we just take a quick measurement, to the center of the hole, that looks to be about a 92. So I'm going to get my inspect tool up here. Default is measure, so I'm just going to hit that. Notice we have the sketch tool and the measure tool stacked. You can use them both at the same time. But I'm just going to go from the center of this hole to the center of this hole. That is 92 millimeters. So we use the edge of the board to make sure the holes are in the correct position. That's what we measured. We should be in pretty good shape. Same for this top one here. Since we know the board size and we measured to the edge, we should be pretty close to where we need to be from the center hole. I'm seeing 122. So we'll reset our measurement here. We'll go from this one to this one, 122. So we're good there. Our only outlier is this one because it's a little higher than the other hole. So we know it's good from the distance from the outside. So the distance from this edge of the board should be fine. We're just not going to be able to tell the distance from this edge very easily. So we'll just go by the distance from this top hole. So center to center looks to be about 79 millimeters. So we'll close our measuring tool just for a moment, and then we'll go back to our distance. So I'm going to click this one, right click, sketch dimension. I'm going to take it down to this hole. It's automatically going to be the distance to the center of the hole. And we said that that was 79. Now we should have the holes in roughly the right location before we start printing. There might be a little adjustment, but we should be relatively close. They're big enough to fit over the standoffs as well. So let's just finish sketch for now. And we said those standoffs were 4.5 millimeters deep. So I want to cover those and then slide this whole thing over them, and then we can put a screw on it with a washer. The standoffs are actually a little bigger than the screws I'm going to use, so that washer will be important. But I'm just going to hit the E key, and I'm going to extrude this center part up. See, we don't have the holes, so it's going to allow those to cut holes. And we're going to make it the same depth as those standoffs, 4.5. So now we have a plate that will fit over our existing hardware that we can mount our new board on. So that should give us a plate that pretty much covers this whole area. Now our new board, again, I want it to go like this, but keep in mind the features that you have on the board. This has some SD cards on the bottom that might be pretty challenging to get to. I'll probably only need this small one here, so I can pull it out just a little bit so I could still slide the card in if I had to. But it's going to be pretty ballpark. We'll just keep it away from the edge. That old board, you can put it back in there to kind of get an idea of where it was setting. The edge of it is very close to the case. So that standoff there that's actually a little bit higher is a pretty good reference to where I want the edge of my board. So we could just sketch out the new board with the dimensions Big Tree Tech gave us. That's probably what we'll do. We can either sketch it out on its own and create a plate, or we can just sketch it on top. So I'm going to go with just sketching it on top of our current mounting bracket. So if you have the drawing, you can go ahead and use that. It's 95 millimeters wide by 160 long. So we'll start there. So I just want my new board to be roughly above this standoff here. So let's start in the center of this rectangle. Let's get a sketch. And let's get a rectangle and go from the center here. So I want to know what the center of my current plate is. Remember, you find your triangles that pop up. So I'm going to go down. Now I know where the center is because of those two blue lines. So 160 long, and then hit tab, 95 wide. And you can move your sketch items. So I know it's in the center of the bracket where I want it, but I want it to come up quite a bit. And this isn't going to be a scientific movement at all. But if you right click any of the objects of the sketch you just drew, you can hit move copy. And then you can select what you want to move. The move box came up. Since you just drew it, you should only have to select one segment. So we'll just go with the bottom one here because that's the one I'm going to line up. It should bring up the arrows and you can start moving it. And again, this doesn't have to be perfect. I just want it to be far enough up that I can put that SD card in if I have to. So I'm going to move it just a little higher than this standoff for good measure, right there. From here, we can start planning out the mounting holes. So we're kind of working on the drawing from the bottom up. So let's just start with this hole. We know how big the rectangle is. Can we go ahead and work out like we did last time? to plot where the hole might be. This one isn't quite 5.5 millimeters away from the edge of the board. Going this way, it looks to be about the same. It's almost 5.5 millimeters. I want to measure some of the other ones to see if that's common. Looks like 5.5 there, 5.5. Looks like all the holes are around 5.5 millimeters away from the board, just a little bit less than that. So again, we'll start with our bottom one. These are going to be 3 millimeter holes because that's the hardware size we're going to use to bolt it down to this other plate. So again, let's just go ahead and add 4 that are the same distance from one another, and we'll adjust them. So let's make them just a little bit larger so the hardware will go through easy. So let's call it 3.1. We'll grab another one, drag out from this one. We'll put it somewhere in here. 3.1. Grab another. Put one over here. 3.1. And then we had one kind of floating around in this neighborhood. So let's go ahead and drag this one down right here. 3.1. And then we go back to dimensions. So this one is 5.5 from the edge of both sides here. So let's click it, right click, sketch dimensions. So from this edge of the board, we're actually going to call it about a 5.4. And then same from this side. And then 5.4 to that one, so we're good with this hole. We'll move up to this top one. From this one, we're good. So let's go ahead and do this one to this board edge, 5.4. But it looks like this one's actually inset because there's a fuse there. So let's take another quick measurement. There's a fuse, so that hole is a little further down. It looks to be right at 9 millimeters away from that edge. No worries. With our dimension tool to this one, let's just call it 9. Then this hole over here, it was 5.4. We'll just continue with our dimensions. 5.4, 5.4. And then our tricky one down here, we could try to get some help from the schematic if we wanted to. So they do have a measurement from center to center on that top hole. So let's go with that. They say it's 97. Let's just call it 97. We'll take the easy ones when we can get it. This one, over to this one. We're going to call that 97. And you have all your lines here telling you the distance. You can go ahead and measure those if you want to, but it's probably not necessary. But now we know where all the holes need to be landed for our new board mount. So we can finish that sketch. Now, as you can imagine, we can go ahead and hit E to extrude. So we'll extrude up because that board does have some thickness to it. But we're not going to include all the components and everything. So let's just call it 4 millimeters for now. And I don't want to join. I'm going to treat this as a new body for now. So let's just switch that over here. If I joined, that would make them fuse together in one body. I'm going to say new body and hit OK. So now I kind of have the layout. New board over the old mount. And looking from the edge, remember this one's going to set over the standoffs. I really don't need all of this extra mass in here. So I can drop this board down a bit and kind of inset it inside this mount. So I'm just going to move this one down to be level with this body here just to see what we're dealing with. So I'm going to hit M, and then I'm going to select this body, but I'm going to select the edge of this body because I want to bring this edge down equal to this edge. So I'm going to select this edge. You can see the different points. I want this one. Make sure this says body. You'll know if it doesn't. You need to switch it to bodies because that's what we're moving, not faces. And I'm going to move it in this direction. When you start moving, then you have the option to snap to something. So I want to snap that edge to this face. So I'm just going to click this face. It snapped it down, negative 44.5. You can see those are equal now. And we can just hit OK. If you hit OK, you're going to reset to 0, so it's going to make just a little bit more sense. And there's no need to make these different heights for our project here. So I'm going to make this one, I'm going to extrude this one up to the same height as this. And this is a trick that I like to do. Now over here in your menu, you can see we have 2 different bodies. You should name these so that you don't confuse them, but this project isn't very complicated. So if you hover over them, it'll show you which one's which. I'm going to take our board mount, our new Big Tree Tech board mount, and I'm going to extrude it up to the face of this one so they're the same height. So I'm going to hit E, click this face, and then click this one. So that brings it up 0.5 millimeter. They're both the same height now. Now I'm going to go over here and turn off body 2. See, that turns off our Big Tree Tech board mount. We want that one. We want to turn off the King Rune mount. Turning that off will keep it from joining that body. We want it to join together with this body we're extruding up. If you didn't, you would have another body on top of the body that's only 0.5 millimeter thick. We want it to join to this one, not the other one, for now. So we're going to hit OK. Now you can turn your other body back on. They're still separate bodies. We can tell which one's which. Now we're going to make these all one mount, but we need our holes in the mount down here. If I just join these together, you're going to lose those 2 holes. So this mount tells us where they need to go in this mount, basically. But that's where your sketch can come back in, because you can always turn these back on. And remember, I'm just showing you how to do different things, how they work, the buttons to click on to make all this stuff happen. Not necessarily the quickest way to get things done. But to combine these, if you didn't want to join it during the extrude, you can just do the combine tool. And that's this button up here. Combine, select one body, select the other, and decide how they would like to combine. You can either make them one as join, so one body. You can use them to cut or intersect. For now, we're just going to do join, so now we have one body. But I still need those holes from the sketch that we cut. It filled those in because we added it to that existing body. So you can always turn the sketch back on. You now have those holes again, and we'll just E to extrude. We'll select both of those, and we're going to drag them down just past the bottom of this. That will start the cut. Now you have holes in that one whole body. So turn your sketch back off. There's your mounting holes. So now we have one giant plate that will mount on the printer and the board. The only thing we really need now is a way to fasten our new board down to our mount. Because these are going to slide over those standoffs. We'll just be able to put a screw and a washer on top of those to hold it in place. But we need something to hold the board in place. And that's where you would want to capture a nut on the back. So for this job, we're just going to use some standard M3 hardware. So a screw like this, that will go through the board, no problem, to mount it up. So with those M3 screws, we're going to use M3 nuts. Now for this project, we're just going to measure the nut. We only have 4 of these, and I'm going to show you a quick way to make these happen. So an M3 nut, I actually happen to know this by heart, but face to face, those are about 5.5 millimeters. So I'm going to go to the top and I'm going to roll this to the side. So this is how it's going to be inside the printer. And it's important to keep in mind where it's going to be at in real life. So that's why I try to show it like this. We want screws to go down through to hold the board on, so we want nuts on the back. So I'm going to rotate to the bottom. And I'm going to make a sketch. Now you can bring actual hardware into these drawings, and we will do that in later videos. But for now, I know it's 5.5, and it's 6-sided. So let's go to Create, Polygon, Circumscribed Polygon. That just means it's going to use the center, so we can use the center of our hole. So let's do that. Since we're on this face, we can find the center of our features. So we'll just click there. It's going to default to 6, or it should at least. You can square it up the best you can, but that whole nut was 5.5 face to face. This is just measuring from the center to one of the faces. So if you did 5.5 here, that would be twice as big as you needed it to be. So in Fusion, you can do math. The nut was 5.5. You can just divide that by 2. So do a slash, 2. That makes it half of 5.5, and hit enter. Now you have a pocket that nut will fit in. Now you might want to make it just a little bit bigger depending on the hardware you're using, but the nice part, if you use pockets like these, you can pull that nut through with the screw, so you can get it nice and snug in the plastic part. So just keep that in mind. You'll see me do that here more in a second. But I'm going to go ahead and make these for all of our mounting holes. So we'll do one more together here. Polygon, center, 5.5 divided by 2. And we'll do one of those over all 4 of our mounting holes. So now we have all 4 of our sketch items, but we need to extrude into the part so we have a pocket to hold that nut. And the ones we will be using are about 2.3 millimeters thick. So since we have room in the board, we have enough plastic to hold the height of that nut. We'll just finish sketch. I'm going to extrude and I'm going to select all 4 of our polygons. 1, 2, 3, 4. And I'm going to do negative since we're cutting into the part. It was 2.3, let's do 2.4, so we make sure that it's down under the surface of that plastic. And that'll cut a hole. Now we have pockets for all those nuts to go in to secure our board on the back side. So this is our basic part. Now remember, on our sketches here, the board, really all we care about is that there's a spacer in between the metal of that printer housing and places to land those screws. So there would be a lot of extra plastic here. So I suggest you just create another sketch around these sketches and cut a couple of holes. It'll save you some plastic. But you want it to still be structurally sound. So what I would probably do is just do a sketch right here and create another rectangle. I'm just going to make it inside the mounting hole so we have enough plastic to mount on. But I'm going to cut it to about right here. Doesn't have to be super accurate. And then I'm going to do the same thing down here and just cut another one. Again, I'm just trying to save plastic as we print it. Something like that. And I'll finish it. And then I'm just going to extrude those. And pull them through. That will add for a little bit of cooling on the back of the board. And just save us some plastic, some time overall. Now you can make this as pretty as you want. You could put some fillets on it. You could chamfer the edges. Whatever you'd like to do. But right now, this is going to be a functional part, and we've already been through a lot in Fusion today, so I'm not going to go into any of that. But now we can just print it, and this is going to be pretty easy to slice. So in Fusion, we'll just do our utility, make, click on it, and we'll export as our STL binary. We'll just call it board mount, and then we'll head to Prusa Slicer, and we'll bring it in. Board mount. Now remember, we're going Z up. The only thing we have to worry about here, I'll go ahead and slice it just so you can see, are those pockets that we made for our M3 nuts. If you flip this over, you can see those aren't supported. But it's a really easy fix. We're just going to flip this whole thing over 180. So we'll use our lay flat tool, and we're just going to flip it to this side so it prints this up. So now we don't have to worry about these overhangs for the nuts. And this should print just fine. We had some different settings over here, but we're going to go with the default that I always use, a 0.2 speed. Print it out of PLA first. If you have some cheap PLA that you want to mock it up, if you're absolutely sure, you might want to use a different kind of plastic. But I'm going to print out of PLA first so I can show you a few things. So let's print it and see what happens. And here's our part printed out of PLA. Let's make sure it's going to fit. By all rights, it should fit over our standoffs if all of our measurements were correct. Remember, we have the spots here to place those M3 nuts, so it would go like this. But let's just test fit it real quick. And it fits over all 4 of our standoffs. So that's a good start. Now let's make sure it's going to fit on the Big Tree Tech board, because it will have to go on before we screw it down to the King Rune here. So just to mock it up, I'm going to lay it over here. And these 2 top corners look good. It's square with the part. Remember, we just kind of drew the whole thing as a rectangle. So I'm going to put these in here, just set them in there to position it on the part, to hold it in place. So we can take a look at these 2 other holes, because we do have some issues. Now, somewhere in designing, I missed these 2 holes. So this one here we got off the schematic. It is definitely 97, but the hole needs to come this way a bit. So when we have dimensions, we can go see what we did wrong. This hole lines up pretty good left and right from what you're seeing, but it actually needs to come back just a little bit, which I was pretty sure we measured all these at 5 millimeters and some change. But let's go see what happened in Fusion. So we'll go back to the top view here. Let's turn on that sketch. You can kind of hover over these to see which one it was in. That's for the M3 nuts. Here's the sketch where we laid out the Big Tree Tech mount. If we take a look at this sketch, just click on it. If you right click, we'll edit sketch. So the 97 is good. Looks like we forgot to set that to 5.4. It was still inset a bit. So an easy fix, we'll click it, sketch dimension, it's set at 6.76. And that was supposed to be 5.4 like the rest of them. So while we're here, these two appeared to be good after we printed it out, so I'm not worried about that. And this hole down here doesn't look like it's this far inset to me. It's good this way, but not this way. So I'm going to edit this dimension. Let's just take the 0.4 off of it. I think that would be enough to fix it. So we're going to bring it a little further out. We'll just change it to 5, and that'll move our hole. So after those changes, we should be able to reprint, and it'll be good. And something to note, since we're using dimensions on everything, if we flip back to bottom, even though these holes that were cut for those M3 nuts were not in the same sketch, we used dimensions. So when we changed the dimensions of those holes on the other side, it brought these shapes with it. You don't want to have to go correct everything one piece at a time. You want to use those dimensions to keep everything nice and lined up. So we'll go ahead and give it another print run. So here's our first attempt. We'll set that aside. Here's our second attempt. Let's see how it's going to line up with the board. And all the holes are lining up much better this time. I think we got it. Now we can go ahead and proceed to put some M3 hex nuts on the back and use some M3 screws to tighten this down. Now I've already done 3 of these, but since we put that polygon shape in here, that hex nut should fit right in, and the plastic should be tight enough that it'll hold it in place. So you can just set it in there, and the best way to line it up is to use a short M3 screw. This is an M3 by 10, but I'm just going to put it through and thread it into that nut, and then just snug that screw up and let it pull it into that place. It'll pull it in, no need to get crazy with tightening it. Just snug it. And since we made it just a little bit deeper than the nut actually is, it's just a little bit lower than flush. A nice fit. But after the board's on, these will stay in place. So all 4 of our hex nuts are on. We can go ahead and put the board in place. We're just going to set it on top and use M3 screws. We don't want to use screws any longer than they have to be because they would touch on the other side. So we'll see how long we might need them. Also keep in mind, there are solder joints and components on the back of this. Don't get this super tight. Best practice would probably be to put this board on just little standoffs. Just printed parts that were big enough to cover that hole. But for the video, I'm just trying to show you how to make a part. I wanted to keep this as simple as possible. No need to overcomplicate it. We'll do that in later videos. And this is going to work for our purpose. But let's go ahead and mock it up with our PLA part. Make sure it's going to fit on there. I'm going to start with these M3 by 10s. They should be long enough to get done what we need to do. And those are the M3 by 10. You can see there's a space in here. You don't want snugging this screw up to put any tension on the board. Best practice would be to print out some spacers or just use some washers that you have. Plastic washers would be best. But keep all those components away from your mount. But I also want to get this as low as I possibly can. But these are just the basics here, right? We have more advanced things that we could do that would design a better part. But for now, PLA, the screw holes fit. That's what I wanted to test. And I'm just going to set it on here to make sure there's no gotchas. It sets in there. It's going to serve its purpose. And then for these standoffs here, we can use an M3 again. A shorter one, probably like an M3 by 6. Something like that we can put a washer on because we're covering up that standoff. So when we have it set where we want it, again, we're just mocking it up, that would hold it in place. So our test prototype part, all the holes look good. We should be ready to make our permanent part. But we're going to do that out of a little bit different filament. So let's talk about PETG. So a word on filament. I like to start with PLA. It's easy to print. That's what we've been focused on up until this point. And I like to mock up the parts in a filament that's relatively inexpensive. You saw we corrected that error. It's not going to be that big a deal to reprint the part. But be sure as you can before you start printing. You don't want to waste plastic. But I like to find something that's pretty inexpensive but accurate. And that can kind of be hard to do. Over the years, I've tried to get a hold of as many of these transitional spools from Printed Solid as I can. You can't always get them. The color is not going to be consistent. This is the filament they run through the extruder when they're changing colors, things like that. It's very low cost most of the time, but I don't care about the color, I just care about the accuracy, and it's almost always accurate. That doesn't get affected. The color's just not going to be very consistent. So this is what I like to mock up all the parts in. You can use any PLA you like, but I suggest sticking with a brand that you know is accurate. For the part that we're printing now, it might succumb to some heat. Those boards do get kind of hot, and PLA might deflect around 60°C. So the next step up would be PETG, but you don't want to print PETG on a smooth PEI surface like we talked about in other videos, like you do with your PLA. It will stick way too well, and it'll probably rip up your sheet. So to get set up printing PETG, it's not that different on a Prusa machine. Some people struggle with it, but on Prusa it will print it just fine. We just have to switch out to it. So we'll take off our smooth sheet, and we'll put on a coated sheet. These are textured PEI sheets. I don't like to use these on PLA. I don't think they stick as well, but they're great on PETG. The satin sheets are fine too, but I really prefer the coated sheet. So we're going to treat it the same way. To print PETG, we'll put it on, we'll clean it with our alcohol, try to get as much of the grease off as possible. Once that's dry, we can go ahead and preheat to load our PETG filament. So preheat PET. And the temperatures are going to be much higher for PETG. I print PETG at 250 on the nozzle most of the time and 85 degrees on the bed. It's a little higher temp filament. It will handle a little higher temp, so the bed temperature is going to be higher. Remember, the bed is here to keep that first layer just a little bit squishy so it sticks to the bed better. Here's our PETG. We're going to be using Prusa. I know it's accurate. It's great filament. I use this stuff all the time. It's going to print a lot like PLA, but it's going to be a little bit stringier. Also, it can be hurt by moisture a lot more than PLA can. It's not as consistent. So you might have to dry your PETG from time to time if you're seeing it get very stringy. But again, on the Prusa printers, it will handle PETG just fine. You shouldn't have any issues, just make sure your sheet is correct. We handle the filament exactly the same way as PLA. We put an angle on it, never let loose of the end. When the extruder is up to the preheat temp, we can just go in, hit unload filament. That'll eject it. You want to pull this out as soon as possible because it does put a bit of a knob on the end of it and that can get stuck. So pull it out while it's still a little bit warm so you don't have any issues. And then you can insert that PETG just like you did PLA and it'll auto load. Since we're going to a higher temp filament, you shouldn't have any issues with the transition from PLA over to PETG. It's going to purge it successfully. And I'm happy with the color. I'm happy with the extruded amount. It looks clear. So I'm going to hit yes. Now remember, in the previous videos, we did the first layer calibration. On the older printers, like the Mark III, the Mark 3.5, you still have to calculate that first layer, or calibrate it. You can see right here it says Smooth 1. That was the calibration for our Smooth PEI sheet. We're now using a textured sheet. So we can create another calibration sequence for our textured sheet, and that's what we're going to do. So we're just going to run that calibration again. Remember, the newer printers, you don't even have to do this. But it's important to know that different filaments, different bed temperatures, might have a different layer height. So we're going to run that calibration. So on the Prusa Mark III, we'll go in, we'll go to Settings, and then go down to Hardware Setup. This allows you to select different sheets. Steel sheets, we've already got a calibration for Smooth 1 for PLA. I'm going to go down to Sheet Textured 1, and we'll do first layer calibration. You can stay at the same offset that you are on PLA. It's going to be relatively close, but the textured sheet is just a bit different. So we'll continue from this offset, we'll just adjust it a bit. And then select the filament you're calibrating for, PETG. It's done the auto level, now it's going to start printing that test pattern, and we'll just adjust it on the fly to make sure we have the proper amount of squish. On the textured sheet, you're going to want a little bit more than you would on the smooth sheet. Be careful, this is a little higher temp. It is 85°C. You don't want to get your finger on there. It stuck pretty well, but I'd say we need just a little bit more. Let's take it to 1 0.575 in the negative, so we're bringing it down. Maybe just a little bit more than that to make sure we have the proper squish. That's a good layer height. And now it will complete the little square there in the corner. We'll take a look at it when it cools down. Remember, always let this cool down before you pull it off. You don't want to hurt the model that you're printing or the sheet you're printing on. But we're good here at that 1.590. And you can flip back and forth in between these sheets in the main menu. So if you go back to PLA, it's still going to have your calibration for your PLA settings. Just go to the main menu, click once. There's your sheet right there. If you have multiples, we're on textured. If you hit it again, it'll go back to your smooth sheet. You're not going to have a ton of different sheets probably, maybe 3 at the most, but these are my main 2 ones. So we're on textured, we're good. You can flip back and forth between those calibrations. And as always, you can peel your test off and take a look at that square. Make sure there's no gap in the extrusion, and we're good. Now we're ready to print our final part in the PETG filament so that it can stand up to the heat that our main board might put out. When you slice for your PETG part, there really isn't any difference. Remember, we had PLA set before. We just want to move to PETG. All the settings you need to change up are going to be in that profile. So just go to filament, change it from PLA over to PETG. Just don't forget to change that back and forth as you're moving your different filaments, because those are going to print at a lot different temperatures. And we'll slice it, put it on our SD card, and we'll print it. And here's our PETG part. You'll notice on the back that textured sheet actually leaves kind of a texture on the part, which some people like. The PEI sheet leaves a lot smoother texture, but PETG does work really well with that textured sheet. Let's go ahead and load up the M3 nuts and we'll get our board on here. For this install, when we put the board on, I am going to go ahead and use those M3x10 screws, but I'm going to use these 4mm nylon spacers. You could absolutely print some of these and they would work just fine. I just happen to have these. With the stuff that we've gone over in the previous videos, you should be able to make these no problem. But the board will just set on these when we screw it down. Keep it level, keep those components away from our printed part. So it's installed on our part. We use those spacers. That gives us enough room. None of the components are touching the part. We should be good. And hopefully we're okay with the height. That's, again, for another video. But we'll go ahead and put it inside the printer. It's a nice fit. The screws aren't too long. They don't go out the back. So it's nice and flush on the case. And we'll go ahead and do our M3x6 and our washers. We have 3 more to do to fasten it down. So there it is. Install is complete. It looks good. We're ready to go ahead and start our project with a board swap on this printer. So there we go. Our board mount adapter is complete. Hopefully there were some tips in here that you can use inside Fusion to create your functional parts. Also, this gets us down the road on our King Rune board swap out project. There will be a lot of videos coming up for that very soon, as well as more back to basics content, but that will be it for today. Hopefully you found this helpful, and I'll see you really soon on the next one.